Okay, now we're going to talk about composition of functions. When you perform operations on functions, which composes a whole new function. So I'm going to show you two different notations. Here we have a function h is going to be added to a function g. So you just bring down the h function, x cubed, subtract 3x, and you add the g function, 3x plus 5. Notice these are two separate functions. We're going to bring down the notation each time. Very important, people. Now what you're going to look for, and we want to keep things in standard form, meaning the highest degree will be put in that order. So x cubed, there are no other x cubes, so it doesn't have a like term to be added. So I'm going to bring down x cubed. The next highest power is just x to the first. Well, look at what we have. We have a negative 3x plus a positive 3x. Well, those cancel each other out, leaving positive 5. So notice when we add those two functions together, we get a completely new function. We might even call that new function j of x. You could call it something else. But notice, if you were to graph those three functions in Desmos, completely different graphs from each other. Okay, now I'm going to move this stuff over. In fact, I will do this. This is the different notation, where instead of it being two separate h of x plus g of x, we have the g plus h in parentheses of x. But the process is the same. But now you bring down the g of x, which is x subtract 3. And this is plus, so plus 2x squared minus 2. And then you bring down the notation again. Remember, these are called composition of functions because we're composing a brand new function based off two given functions. Here we have the x squared, and that's positive 2x squared, and there's no other x squared, so we just bring that down. And the next highest power is x. There are no other x's, so we bring down positive x or plus x. And then what we have left is negative 3 plus negative 2, which is negative 5. So if we wanted, we could give that a completely different name. We don't have to. That's not part of this. I'm just showing you how you take two separate functions, perform an operation, in this case addition, and now you have this completely new function. But this is the notation how you would write it. This is just my spin. All right, that is it for this one.